Good day. We'd like to present you our article, Scientific Research, topic of Information System Model for Analysis Viral Infections Data based on Machine Learning. Problem relevance. The use of modern tools and approaches for data analysis make it possible not only to research and evaluate statistical indicators, but also to perform more complex tasks, including predicting future values using machine learning as a field of artificial intelligence. In the context of data analysis, one of the current research directions is the issue of viral diseases. Although COVID-19 has become less critical due to regular vaccinations, infection prevention and the use of preventive measures such as quantities, viruses haven't disappeared from the planet and continue to mutate. Identifying diseases patterns, forecasting, and other analyses can help prevent to the future spread of the virus. Automation of symptom detection and human body reactions to viruses is essential, as it enables faster modifications of effective vaccines and the introduction of various protective measures into the virus transmission environment. The purpose and objectives of the work. The article's goal is to study the dependencies of various indicators of virology using data analysis models, creating a cross-platform information system model for practical purposes. The work objectives are analysis of literature in the study area and description of the problem, project structure development as UML diagrams and component interconnections, machine learning models implementation with the help of programming language Python and couple functional libraries, experiments and results analysis, and future steps for system improving proposal. Problems and solutions. We would like to pay attention to such things that assessing the automation data analysis for various diseases can help identify the source of the virus, its symptoms, and prevent its further spread. Collecting such information is a challenging aspect due to the need for access to medical databases of conducting surveys of infected individuals. It's a big problem because we haven't got any big data sets of actual modern information. This complexity reduces the speed of information updates, and the human factor may compromise data reliability, especially when dealing with a significant number of input features. To solve this task efficiently, it might be proposed such a solution that it's important to use the right methods and algorithms during data collection and pre-processing, including machine learning. Specifically, among contemporary approaches in this direction, dimensionality reduction methods such as PSC and are relevant to facilitate the transformation of data into a form suitable for sequential analysis and interpretation of results. The efficiency of data analysis for such data largely depends on the models used and their hyperparameters values, because it's a big problem to find the most convenient and effective efficiency hyperparameters values. Some of less deterministic machine learning models may perform data analysis quickly but produce inaccurate values and lack sufficient generalization capability. On the other hand, most stochastic models may take longer to perform computational operations, but their precision will be higher as a result. For both cases, setting the right attributes for the models and their relationships with each other is a critical factor. So we discovered to develop information system model, and on this slide we can see use case diagram. We can see that simple user can make an authorization, can import data, visualize data, analyzes data, and he can do registration. All the functional program code is developed with using Python language and integrated development environment PyCharm. Also, we used Jupyter notebooks. On this slide, we can see sequence UML diagram that shows that user choose model. In data model, can see the parameters of model which he wants to create, and after inputting parameters and start the process of training a model and building a machine learning model, he can get the results on the analysis model and see the final plots with graph and results of metrics. On this slide, we can see components diagram with the main components of our system model, which includes models component, utils component, five different components for each algorithm of machine learning that we used. Gaussian, native bias, random forest, natural networks. There are two types of model, perceptron and deep natural network. The decision tree and support vector machine model. We use the we collect the data set from different sources which contains information about patients who underwent COVID-19 testing with a total of 5,434 rows and 200 more columns. Of course, we used the PCA method to properly process the data and to reduce dimension of features. On this slide, we can see the results of research, important weights with native bias and the confusion matrix for decision tree. On this slide, we can see the results for random forest model, weight importance, and also the results of confusion matrix for random forest. We can see results is more convenient, more better than a native bias. On this slide, we can see comparison of the time performance of the created models, of all models, 6 models that we made. We can see that native bias is really fast. Decision tree is two very fast models. The model that has the highest score with accuracy is natural network number 2. It's a deep natural network, but also it's a very slow model, as we can see about 300 seconds it was building and work. As a conclusion, we can say that the native bias and decision trees have the minimal operating speed. Random forest, due to its complexity, operates more slowly, but the quality is higher. Therefore, the development model is sufficiently functional and allows us to do the exploration of data sets to uncover hidden patterns with the data, not only with our data that we collected, but also with different data sources and data patterns. As a result of this research, the software model for the information system has been developed, capable of performing data pre-processing and analysis steps related to the human virus-related illnesses using machine learning methods. The following evaluation criteria for the models were determined: speed, accuracy, predictions, best hyperparameters. For the models, actually we did it with grid search. Error matrix assessment. The research findings have established that the most effective models are artificial natural networks. But decision tree also shows one of the best results, especially a random forest, considering this model is based on a basic algorithm, and the study also revealed the varying speeds of different models with a significant workload dependence of the chosen hyperparameters values. Additionally, data inaccurates can complicate the process of determining the best model. Therefore, it can be concluded that the best model of working with data collected during the development of the system is a natural network. However, its speed is significantly lower than the decision trees model, so it's kind of a problem to deploy it in production, but it's the new field of our future research. Thanks for your attention.